So, hey, hello, and welcome to the show. It's me, JP. It is time for JP's product pick of the week. Thank you for stopping by. For some unknown reason, Facebook doesn't want to start today, so you're probably not over there watching me, but you may be on YouTube. You may be elsewhere, and if you're elsewhere, because yes, we do have a YouTube chat. Hello, Dave Odessa, Quinman16, Michael Johnson. Thanks for stopping by. But if you're somewhere else, and where's the chat? Well, you can head on over to our Discord. That's it right there. Just go to adafruit.it/Discord. You'll join our Discord server and then look for that channel right there called Live Broadcast Chat. That's where most of the chat is happening. Hello to Thin Man and John Nodge, Jim Hendrickson, Paul Cutler, Liz, C. Grover. Hello. Thank you all for stopping by. So I've got a pretty cool product pick here for you today. I think it's pretty neat. I think it's pretty useful. And I've got a big discount for you on this. So if you want to go check it out in advance before we reveal any more, go to that URL right there. That has the URL and the QR code on it that'll take you to the product page. Inside the product page, this show is being broadcast, so you can see that picture-in-picture style. And you'll see that the product has been released. We had a bunch stowed away. The new products team unstashed those, slashed the price in half. You can get up to 10 of them, no resellers, but you can get up to 10 of them if you have big plans with this product pick. But I can't tease it anymore. What I'm going to do is have Lady Ada just jump back in time a little bit and tell you all about it herself. So take it away, Lady Ada.
The BQ25185 solar USB DC LiPo charger with a 5-volt boost converter. This is a little bit like a less expensive but also kind of better and more flexible power boost 1000 or 500C. I've kind of upgraded all the components, so you can use USB-C, you can use DC power, you can use solar power. This is a solar power supporting chip. It's very flexible about what voltages you use, so it's, you don't have to worry about the previous like Power Boost series was very sensitive. You couldn't go above 5-volt charging. This one, if you fluctuate up to 18 volts, it's totally fine, although it's a linear charger. And there's a little boost converter on the output, which will give you 5 volts, 1 amp output. So it's a tiny little board that kind of does everything you want with a LiPoly or lithium-ion battery. It charges by default with 1 amp, although you can set that to 500 milliamps if you want. You plug in the battery, you charge it, you get 5 volts out. When the power is plugged in, it will automatically use the USB or DC or solar power to input into the 5-volt boost, so you get like the highest efficiency, like you don't end up discharging your battery. And it's nice and small with lots of mounting holes, so it's, I think, going to be a good solution to people who are like, look, I just want basically a DIY power pack that I can use solar or USB or DC power, get 5 volts out, and it doesn't like auto shut off if the current draw is too low. So it's nice and efficient. And so far I'm really liking this LiPo charger. It's been really good, and I've used this boost converter chip for a long time. It's also very reliable. So a nice little all-in-one package to make your 5-volt projects portable.
Yeah, that's right. That's what it is. Hey, look, I've got one right here. You can see it. What's that? Yes, that right there. That is the BQ. Oh gosh, I gotta look that. I'm never gonna say that off the top of my head. What's your name? 2525. Oh, it's written right there at the bottom. Hey, look, that's the product pick of the week this week. It is the BQ25185 5-volt boost board. So this is, like Lady Ada said, a perfect replacement for things like the old Power Boost 500 and the Power Boost 1000. This is for making your projects mobile. So you can connect a LiPo or LiPoly battery to this. You can then charge it over USB-C if you've got some wall wart or some other battery, a battery into a battery. You get battery inception. You can use a solar cell on it. You can use a DC plug on it. We've got all the ports you need for that. And then we have a really versatile output. So this is a set of screw terminal blocks for your 5-volt boosted out and ground, which you can then wire directly to something, hook up a USB port to that, which is what I've done in a little demo project I'll show you in a second. And then you can be on the go. You can always be charging up that battery and then running off of the battery or running off of the better supply. Whichever power line is better is what it's going to pick there. And it's also got some indicator lights on it, so you can see fault, you can see charge, you can see battery. We've got, for this one, you're going to want to use something like, probably something bigger than this, but starting at a 500 milliamp hour battery. So this would make for a really nice, neat, small contained charger, tiny little charger you can carry around and then charge it a lot of different ways. Up through something like one of these 2500 milliamp hour batteries. These are nice. Or you can use some of the, I'll show you here. I won't go into the full demo yet, but you can see I've got one of these nice 4400 milliamp hour batteries, and we even have one larger than that. So you can get a lot of battery hooked up to this and then charge this on the go a bunch of different ways. What else is there to say to it? We've got 5 volt, 1 amp max output. So this isn't for your huge current draw types of projects, but it is great for charging things on the go, for maybe charging up another battery pack, for running microcontroller projects. I'll show you a little sort of LED 5 volt USB light project. You can very often what you'll want to run on this will be USB style 5 volt USB projects, but you can also hook up direct DC to it if you want. We've got an enable pad on there, so that's one of the pads that's exposed on the bottom there. In fact, let me show you some nice photos you can see there. So we've got running across the bottom there, the last pin you'll see says enable. You can run a switch from that to ground and then have yourself a little on-off switch. One of the nice things about this, as Lady Ada mentioned, is that it will not shut off when there is low or no current draw, which is what most of your commercial battery packs do. So this type of battery pack, usually these want something on so that they'll stay on, which kind of makes sense, but for microcontroller projects, they will often be drawing very low current and you don't want them shutting off. So do it yourself, use this type of boost and this type of battery, and you can do a little DIY mobile project. We've also got some nice mounting holes on there, as you can see on my demo version of it. You can also see there on the images there, but I've got it on some little M2.5 standoffs there to hook it up to a swirly grid. We'll take another look at that in a second, but before I do that, let's have a look at the product page. So here it is. It's product ID 6106. So you can get there by going to adafruit.it/6106. You can see we got it on sale right now for $4.48. There's some new video that you saw. Here's this current video, live streaming right there, and then some nice photos, front and back, side angles. And then if you scroll down, you can get to a link to the Learn Guide, and this will give you a nice pinout page here where you can see what have we got going on here. So you can solder this into a perma-proto board or onto a breadboard, depending on how you're using it, or onto a custom circuit board. You can see what we've got here are the USB-C connector. That's for powering, so you can run that from a wall wart or a computer or something. We have V-in, and this is where you're going to plug in something like your solar panel, like I've got going on. I'm going to break everything here by moving this. On this example, I've got a little solar panel plugged in over V-in and ground. Then we also have a VU, that's the input power from the USB plug that's coming in, and then we have ground. There is also a data plus, data minus if you had a project where you wanted to pass those through as well for some reason. You could get maybe a laptop powering this, and you can still grab the data off of that for whatever your project requires. Then you can see we've got a JST connector for the battery input up at the top, or rather battery output, I should say. This is charging out to the battery. And then we have the terminal block output off to the side, and that's the boosted 5 volts and the ground. And that's what I've, in my case, connected up to a USB breakout so that I could plug USB into it. There's the D plus, D minus for the data lines from the incoming USB. There's that enable pin that I mentioned for on-off. And you can, if you had a reason to change your charge rate to a gentler 500 milliamps from the full 1 amp, then you can cut this jumper that's on the bottom there. And then this talks about the 3 status LEDs that we have. So there's the 5-volt output LED, and that's green. That'll let you know that you've got 5 volts coming out, that you're running something on it. We have a charge LED in the corner that goes amber yellow to let you know that you are charging the battery. And then there's a fault LED to let you know if there's some over voltage fault, temperature, thermal regulation fault, some reason that it's not properly able to charge your battery or to power your project. And then if you head to the downloads, you can take a look at the data sheet for the BQ25185 as well as the PCB file and fritzing object for this if you want to fritz this into your projects. So a nice, if you go and look at the product page here, you'll see under the Add to Cart button, which you should definitely consider, we have a little link here to the panel that I'm using, which is this nice little 6-volt 2-watt panel. Pretty neat little panel. I will mention you'll want to get one of these adapters to go with it. This specific one, I think the link is generic on this page to a different connector that won't fit, that has a 1.3 millimeter socket. This one actually needs the 1.1 millimeter socket. And then this goes out to the sort of more standard 5.5, 2.1 DC jack that you can plug into anything. So let's take a look then at the little setup that I've put together here. So you can see I've got my little 2-watt 6-volt panel. I can just put this outside and charge up the battery from it, which is great. I've got the BQ25185 5-volt boost board up here in the corner. I am charging it right now off of USB-C. I can unplug that and you'll notice that I'm still running power, 5 volts boosted from the battery out to whatever I've got plugged into USB. This is just a little USB-C breakout that I have wired into the little screw terminals there. And then you can see my input side on V-in and ground is coming from the solar panel there through the little DC power adapter. So I've just zip tied a nice 4400 milliamp hour dual cell battery there. And then what I'm running off of it, actually, just for convenience, I put a small little USB-C to USB-A hub on the side here. And I have one of these very bright, I'll turn it, I won't point it at the camera. I have these very bright little LED rings that are great for doing some little local illumination. So you can see this is all powered from, zoom out a bit more. Oh, I broke my, I broke the, there was a little click in the camera arm the other day, and I think I snapped a piece of plastic that holds it up, so I can't go all the way out. But there you can see this probably is not actually charging that cell in a weird infinite power loop, because LEDs don't really do a lot for these. This really should be out in the sunlight. But you can see here, this is all self-contained, charge off of the sun in this case, charge off of USB-C. The battery power is being drawn in this case, but it'll charge the battery when we plug in. And that is now running over USB-C to plug in whatever I want. If we unplug my USB-C output there, let's plug in a microcontroller. Hopefully this will at least light up something. This is a Feather. Let's see, do I have a double-ended USB-C? I don't. I'm going to have to plug that hub back in. Okay. This is a little Feather, I think RP2350, and I will give it, I'll unplug this LED light. I'll give it power from the battery over that little hub there. I just saw a little green LED light up there, so it's trying to do something. I don't know what this one's programmed to do. But this project is now powered from battery, and the nice thing is, if this is, particularly if you're doing stuff like gathering sensor data or broadcasting that up through a Wi-Fi hotspot somewhere, this is going to run off of this battery and off of solar, so depending on your current draw, this could just be a perpetual project, which is nice. And if you did need to, you could run in and goose that by plugging in USB-C power. You can see that's now charging up that battery there off a USB-C. But this is running here. I can plug in. I should be okay plugging in a couple things on this little hub, actually. So you can see these are both running off of my little power bank there, boosted up really nice. The other thing I like about this, like I said, is it's nice and small. It's self-contained. You really could build yourself a little small DIY battery bank with something just like that, and then any of a number of DIY USB-C outputs that we have could be run off of here, and give yourself maybe a little on-off switch, and you can charge that when you need to over USB-C. So really great for all of those types of mobile and battery bank charger projects that you might want to do. Let's see, any questions over in the chat? Someone asked about the difference between this and the BQ24074. I am not sure. I would check the data sheet that we have over here in the Learn Guide. So if you head to the Learn Guide, you can head over to the data sheet. Check that out. You can compare that to the other one that you mentioned there. Someone in the chat posted, John Nodge said the BQ25185 has a slightly higher input voltage, is smaller, sports different onboard connectors. Okay, yeah, so you'll want to look into some of the different offerings that are out there. Let's see. Yeah, like I said, this is a 6-volt solar cell nominally. It can vary from there, and this I've had this out in full bright sunlight, and it's had no problem. It's been able to charge up that battery off of the solar without complaint, which you might not find. You might need a specific 5-volt solar cell to do other boost converters that are out there, but this one seems happy with these little 6-volt Voltaic brand solar cells, which are pretty cool. All right, let me see. Anything else? Any other questions? Let's see if we've got these still in stock. We do, yes. So go grab a couple if you're interested in some battery boosting projects. Doesn't have to be solar. Can just be your way of charging on the go and powering on the go. A lot of good uses in your projects for that. Okay, I think that is going to do it. So that right there is my product pick of the week this week. It is the BQ25185 5-volt boost board. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week, and we will see you next time. Bye-bye.